This is the solution video for Unit 1 review, problem number 22. All right, so it says write the equation of all horizontal and vertical asymptotes. All right, so one thing that I want you to notice is that I've given you two different versions of this function, right? So basically, I have the original version in polynomial form, and then it says equals this. And so I've given you the factored version. So I've just tried to make this thing a little bit easier for you. All right, so remember, horizontal asymptotes are going to be evaluated when the limit as x approaches infinity or negative infinity if there would be a difference. All right, so I'm going to use this first version on the left. So I'm going to take 2x cubed. I'm just going to write the limit as x approaches infinity of f of x. All right, and so what would I do? I would plug in, and so of course I get infinity over infinity, right? And so that means we're going to use our strategy of dividing by the highest power of x, right? All right, so that means I'm going to divide everything by x cubed. So limit as x approaches infinity. All right, so that's going to be 2x cubed over x cubed, which is 2, plus 5x squared over x cubed, which is 5 over x, minus 37x over x cubed. So that's going to be 37 over x squared, plus 30 over x cubed. All right, then divided by, all right, now I've got 15x cubed over x cubed, so that's going to be 15. All right, sorry about that. All right, and then plus 125x squared over x cubed, so 125 over x. All right. And then I've got plus 210x over x cubed, so 210 over x squared. All right, so then I'm going to reevaluate, right? So I plug infinity in. So I get 2 plus 5 over infinity. So 5 over infinity in a limit problem is 0, minus 37 over infinity squared, which is 0, plus 30 over infinity cubed, which is 0. Divided by 15 plus 125 over infinity, which is 0, plus 210 over infinity squared, which is 0. So I end up with 2/15, right? And so if this was the limit as x approaches negative infinity, there would be no difference. It would be 2/15. And so we can say that there is a horizontal asymptote at y equals 2/15. All right, so now vertical asymptote. All right, so now what we want to do is we want to set the denominator equal to 0. All right, and so if I have 5x times 3x plus 7 times x plus 6 equal to 0, we can get that 5x equals 0, so x equals 0. 3x plus 7 equals 0, so x equals negative 7/3, or x plus 6 equals 0, so x equals negative 6. All right, so now what that means is that these are the three spots that are potentially vertical asymptotes. All right, so then what we need to do is we need to evaluate the limit as x approaches 0 of each of those. Now, I'm going to use the other version. All right, so I'm going to write 2x minus 5 times x plus 6 times x minus 1. All right, all divided by 5x times 3x plus 7 times x plus 6. All right, and so if I plug in, right, what am I going to get? Well, I'm going to get 2 times 0 minus 5. So that's going to be negative 5 times 6 times negative 1 divided by 0 times 7 times 6. But that's just 0, right? So I get negative 5 times 6, so that's going to be positive 30, right, over 0. So now what do we know? We know that this thing would be approaching an asymptote, right? And so remember, we can pick from the left or from the right. So I'm going to take from the left. So if I say 5 times 0 from the left, that's going to be 0 from the, that's going to be a negative, times positive 7 times positive 6, that's going to be a negative number. So I get a positive divided by a negative, and so that is going to be leading me to negative infinity, right? So remember, all we need to show is that limit from left or from the right is an infinite value. So there's a vertical asymptote at 0. All right, next, let's take negative 7/3. All right, limit as x approaches negative 7/3. All right. All right, and so once again, 2x minus 5, x plus 6, and x minus 1. All right, divided by 5x, 3x plus 7, and x plus 6. All right, so now, numerator. All right, 2x. All right, so this is where things get a little tricky. All right, I don't want to do all the work here. Negative 7/3 times 2, right? So that's going to be negative 14/3 minus 5. That's going to be a negative number. Times negative 7/3 plus 6. Well, that's going to be a positive number. Times negative 7/3 minus 1. That's going to be a negative number. So my numerator is some positive number that is not 0, right? All right, what about the denominator? Well, 5 times negative 7/3, that's going to be a negative, times 3x plus 7. So that is going to be 0, right? And then I've got negative 7/3 plus 6. That's going to be a positive. So, okay, now I want to think, all right, well, the denominator is going to be 0, but, okay, let's approach from the left or from the right. How about from the left? All right, so the first number is still going to be negative. Second number, all right, if I'm approaching from the left of negative 7/3, how about like negative 3? 3 times negative 3 is negative 9 plus 7. That's going to be a negative. So my denominator is going to be a negative times a positive. So that's going to be a positive. So I'm approaching positive infinity. And so we can definitively say that there is a vertical asymptote at x equals negative 7/3. All right. And then lastly, we have the limit as x approaches negative 6. All right. So now one thing that I want you to realize is that x plus 6 could reduce, right? And so that would mean we're left with 2x minus 5 times x minus 1 over 5x times 3x plus 7. And so x plus 6 is no longer a factor. So if we plug in, we get 2 times negative 6, right? So negative 12 minus 5, negative 17 times negative 6 minus 1 times negative 7. So the numerator is going to be positive, right? 7 times 17. So that's going to be 70 plus 49. So 119, right? Divided by, all right, the denominator. Now I get 5 times negative 6, so negative 30, right? Times 3 times negative 6, so negative 18 plus 7 is negative 11, right? So this is going to get me, all right, positive, right? 330, right? And so positive 119 over positive 330. So what does that tell me? Well, it tells me that negative 6 is not an asymptote. So we can say vertical asymptote at x equals 0 and negative 7/3, but not at negative 6.